Dividing complex numbers is quite a bit more involved than any other operation that we've done so far. In order to understand the motivation behind division, let me just write something. If we were to do something, look at a fraction like 3 over the square root of 5. This is often viewed as not a simplified form because we have a square root in the denominator. So when we have something that's a complex number like 2 plus 3i over 4 minus 5i, remember that I is the square root of -1. So it's like we have a square root in the denominator. And that is not our most simplified form. And so we want to be able to take something like this and simplify it so that we get that square root out of the denominator. In other words, we want to remove I from the denominator. And the way that we're going to do this is actually the same process that you normally follow with when you have got radicals in the denominator. We're going to use what's called the conjugate. And the conjugate with complex numbers, we just call them complex conjugates. And that's when you have a pair of numbers, complex numbers, and note that the only difference between them is that the imaginary parts, one's positive, one's negative. Okay, those are what we call complex conjugates. Okay, where the real part is the same, the imaginary part is just the opposite sign. The way that we notate this is with a line over the number. So this right here says that the conjugate, the complex conjugate of a plus bi is equal to a minus bi. Now, the reason we like complex conjugates is because when you multiply a complex number by its conjugate, you get a real number. And let me go ahead and just do this example and show you how that happens. What I'm going to do is I'm going to multiply by 4 plus 5i, and I'm going to multiply by that in the numerator and the denominator. So this fraction, because it's the same thing in the numerator and denominator, this fraction is 1. And so multiplying by 1 doesn't actually change anything, but it will change the form, but it's just not the number. Okay? And notice what happens here. I'm going to do the denominator first because it's pretty dang cool. We're going to take these two things and multiply them. So we need to distribute. So that gives us 4 times 4 is 16. And then 4 times 5i is 20i. And then negative 5i times 4 is negative 20i. And then finally, negative 5i times 5i is negative 25i squared. Now, before I'll do the numerator as well, but let me first just simplify this denominator so you can see. The 20i and the minus 20i, those cancel each other out, which is awesome. We know that I squared is -1, so this is plus 25. So now I just have 16 plus 25 in my denominator. That's 41. So notice that taking this complex number and multiplying it by its complex conjugate, it gave me a real number. So I no longer have a complex number. In other words, I don't have a square root or radical in the denominator. And now I can do my numerator. Let's go ahead and do that. We've got 2 times 4 is 8. And then 2 times 5i is 10i. And then 3i times 4 is 12i. And 3i times 5i is 15i squared. And then we can go ahead and combine some like terms. 10i plus 12i is 22i. And 15i squared, this is negative 15. So I've got 8 minus 15, which is negative 7. So I've now gotten rid of the square root of -1, the I, in the denominator, and then I can simplify just a tad. We like to write quotients with complex numbers in our standard form a plus bi, and so we just group here. We take -7 over 41, and then plus 22 over 41 times the I. So that's our standard form. That's what we like. So that's how we divide complex numbers. You just multiply the numerator and denominator by the complex conjugate of the denominator, and that will give you a real number in the denominator. And then you can just take that and apply it to each of those parts, the real part and the imaginary part, to get your final answer.